Okay, let's get started. So since we didn't have the tutorial on Monday, we're going to go through the solutions today. And then tomorrow we're going to finish the chapter on moments of inertia. Okay, and then that will be everything you need to know for the quiz next Monday. Also remember, it doesn't affect us, but next week, Tuesday, is following the Friday timetable. Okay. Yeah, so we don't have the lecture on Tuesday, so that's fine. But your other lectures for Tuesday, that's going to be Friday now. Okay. Okay, so let's go with the solutions here. So number one, we've got the parabola y equals x squared and the straight line x. So a quick sketch of that. It's going to look something like that. And we know they intersect at 1, 1. And then at the bottom here, they intersect at 0, 0. Okay, so just a rough sketch like that will help us out. Now we want to take this region that's been shaded in and rotate it around the x-axis. So we can just do a little arrow like that so we know the axis of rotation. Okay, so we see that just above the axis, we've got that empty space over there. So when we do the rotation around, that's going to end up being hollow in the volume. So since we've got that hollow part, we need to use the washer method. If this was just solid, then we could use the disk method. Okay, but here we're going to have to use the washer method. So a quick sketch of the volume here. It's going to look something like this. So that outside line over there being rotated around, that's just going to make a cone. And then that parabola part, we can just put that in that hidden detail line. It's going to look something like this. Okay, and then this bit here, that's going to be the solid part from that shaded region there. Okay, and the axis of rotation goes through the middle like that. Okay, so we can see from the axis of rotation to the parabola, that's going to be, yes? Oh, no, you don't need to do any of that. No, that's just for me to show you where the region went. Yeah, no, you don't need to do that. If it helps you see what it looks like to set up the integral, then you can do that, but I don't mind. Remember, these sketchings over here, that's for you to see where the inside radius and the outside radius are. I'm just worried about you setting up the integral and solving it. Okay, all of this stuff is for you to see what's going on. Okay, so we've got our inside radius there, and we've got our outside radius, and we can see that from the volume. If we look at the axis of rotation, from the axis right out to the end of the shape, that's to the line, so that's the outside radius. From the axis to the curved part, that's going to be the inside radius. So R out, that's going to be out to the line, so that's x. R in, that's going to be to the parabola, so that's x squared. Okay, and that's everything we need to set up the integral. So the volume, v, that's going to be the integral from 0 to 1. Okay, that's our x bounds over there between the intersection points. We got the pi. Then it's going to be r out squared minus r in squared. Okay, if you swap those by accident, you're going to end up with a minus sign for your volume. Okay, so just note, if you do your integral and you end up with a minus sign, it means you've just swapped something there. Okay, so it should be out minus in, so that you have the larger volume minus the smaller volume. You don't want to have a smaller volume minus a larger volume. Then you're going to end up with a negative. Okay, so that's going to be pi integral from 0 to 1. R out, that was just x, so it's going to be x squared. R in was x squared, so that's going to be x to the 4. Okay, please don't forget to square them. Okay, it's R out squared, R in squared. Okay, so that's pi 1/3 x cubed minus 1/5 x to the 5 from 0 to 1. Easy to substitute. The 0 doesn't do anything, so we just have a third minus a fifth with the power still. Okay, and that's going to be 2 pi over 15. Okay, again, if you swapped your in and out, then it would end up being 1/5 minus a third, and you'd end up with a negative. Okay, so that's an easy way to spot if you've swapped something. Okay, any questions on this one? Okay, so once you've got your inside radius, outside radius, then it's just the usual washer method formula over here. Okay, please note for the three methods, these equations won't be given. Okay, so you will need to know them. So disk method, washer method, shell method, these volume integral setups, you do need to know those three. Okay, number 2. Okay, so here we had a very similar shape to the first one, but a different axis. So let's sketch this. So same shape as before, so something like that. Okay, again, there's 0, 0, here's 1, 1. Okay, but now we're rotating around y equals 2. So previously we rotated around the x-axis, or you could call it y equals 0. Now it's y equals 2. So that's going to be somewhere up here. Okay, so what this does is it just shifts the inside radius and the outside radius by that 2. So now instead of measuring from y equals 0, we're now measuring from y equals 2. So it's that shift that you need to look out for. Okay, so inside radius, that's from the axis to the first line that we see. So from the axis going down, the first thing we see is the straight line. So that means the inside radius is 2 minus x. Why 2 minus x? Well, because we want the top part. If the full distance is 2, the bottom distance is x, because y equals x, then that top distance with the arrow line, that's 2 minus x. And then r out, that's the other one. So r out, that's going to be 2 minus x squared for the same reason that r in is 2 minus x. Okay, again, we've got that shift in the radius. Okay, what's this going to look like as a solid? Okay, again, you're going to have a very similar cone sort of shape, but now the straight line is on the inside and the parabola bit is on the outside. So fairly similar. It's going to look something like this. Okay, the parabola bit is on the outside, so it's kind of curved. And then the straight line on the inside, so it's like something like that. Okay, it doesn't need to be pretty, just a rough idea so you can visualize it before you do the work. Okay, so the volume, that's going to be the integral from 0 to 1, same times as before, because those are the same intersection points there. Okay, so we're going to have pi r out squared, so that's 2 minus x squared, all that squared, minus r in squared, that's 2 minus x, all of that squared. So all of this in red, that's r out, x squared, everything, and then this in blue here, that's r in, and again, all of that squared. Squaring this is not so bad, so we're going to get pi integral from 0 to 1. We're going to get 4 minus 4x squared plus x to the 4 minus, and then that other there in brackets, that's going to be 4 minus 4x plus x squared Any questions on this one? Okay, so if the axis of rotation is shifted, then your radial arm must also be shifted by that amount. Let's look at number 3. Okay, so here we had the tan graph. So that's going to look something like this. We're only interested in the positive part, so I'm not going to draw the negative part of that. And it cuts off at y equals 1. So this is tan x, that's y equals 1. If that's y equals 1, then this will be pi over 4. Okay, because tan pi over 4 is 1, so that gives us our bounding region there. I've seen a lot of students shift this over. Okay, remember the tan graph starts at 0. Okay, a lot of students were shifting it over and starting at pi over 2. Okay, please, if you can't draw your graphs, please go over that. Okay, sine, cos, tan, you do need to know how to sketch that for the section. Yes, here starts at 0. And we want to rotate this around the x-axis. So that top line, the y equals 1 line, if we rotate that around the x-axis, we're just going to get a cylinder. Okay, so that's like the edge of the cylinder when we rotate it around. And then that tan bit over there, that's just going to be some inside part of the cylinder. So let's draw a cylinder first. Okay, so that's like the y equals 1 line being rotated around, you end up with the cylinder. And then on the inside, we just have the tan line being rotated around. So that's going to look something like this. Something like that. So the tan bit here, this is over here, this is over here, and this is over here. So from the two pictures, we can see that the inside radius goes to the tan because that's on the inside. Inside radius is on the inside. And the outside radius that's going to go to the y equals 1 line because that's on the outside. Okay, so R in, that's going to be tan x. R out, that's going to be 1. Okay, so again, inside radius, that's going to be on the inside of your volume. So once you sketch your volume, you can see what's what. And the outside radius, that's the outside of the volume. Okay, and x goes from 0 to pi over 4, we did that in the picture there. So b equals 0 from 0 to pi over 4, pi r out squared, that's going to be 1, r in squared, that's just going to be tan squared. So that's going to be, here we can split this up. If you know it in one step, if you know the integral of tan squared, that's fine. I'm going to split it up. So we're going to have pi integral from 0 to pi over 4 dx times pi integral 0 to pi over 4 tan squared x dx. And we can just work with that separately. So the first one, that's just going to be pi over 4 times pi, so pi squared over 4 times pi. So we have covered this one before, the integral of tan squared. So that's tan x minus x. Okay, if you remember that from what we covered with the three integrals, you can just write it down. It's fine. If you forgot that, then you need to recalculate it. Remember the identity for tan squared. Okay, so here, if we just go sine, remember sine squared plus cos squared is 1. If we divide through by cos squared, then we're going to get tan squared plus 1 equals sec squared. If you forget that, just do it on the side quickly and then we'll get the answer. So tan squared, that's going to be sec squared minus 1. And with that quick substitution there, we can do the okay, the derivative of tan is sec squared. that from what we did before, you can skip the middle step and just write the answer. But if you want to do the extra working, that's fine as well. Okay. So this is going to be pi squared over 4 minus pi tan of pi over 4. That's just going to be 1 minus pi over 4. Then the pi goes inside, so we have pi squared over 4 plus pi squared over 4, so that's pi squared over 2. And minus pi over. Any questions on this one? Again, I remind you for your June exam, the just method, watch method, show method is going to be just under 30% of the exam. Okay. And another 30% for general integration methods, so use substitution, use substitution, integration by parts, rational functions, all of that stuff. It's another roughly 30%. And then the rest of it is smaller sections that we covered in between. Yes. Sure. That was just from the balance that we did. So it needs to be above the 10 mark and below the 1. So if it's above the 10 mark, that's going to be over here. If it's below the 10 mark, that's going to be over here. Yeah, so just look at the bounds. So if the bounds on the y-axis, y equals 1, and the tan graph, it's going to be above 10 marks. Any other questions? Number 4. So here we had similar to number 3, but again we shifted the axis. So let's skip that. So it's going to be our tan width like we had before, and y equals 290. And we're rotating around that. So same idea as before. We want to find the inside radius and the outside radius, but now we're measuring from this new axis, not the x-axis. So from the axis to the straight line, that's going to be the inside radius. And then from the axis to tan, that's going to be the outside radius. Again, if you don't see that immediately from here, you can sketch the shape. So it's going to be something like this. More curved than that. So it's sort of like a cylinder, but it's a bit curved. Yeah, that's 10x. So again, the full distance is 2 minus the red part is the part that we want. So we have everything we need. So we have volume equals pi integral from 0 to 1, 0 to pi 4. So the y value is 1, so the x value will not 0. So please remember, when you substitute the top, you get your first bit. When you substitute the bottom, y cubed will be 0. And e to the 0 is 1. Okay, please don't leave that out. So pi 1 half e squared, because y is just 1, minus 1 third, minus, and now when we put in 0, y cubed will be 0, but e to the 0, that's going to be 1, so you end up with just a half. And a lot of students were ignoring the half there. Okay, please remember that bit. So that's going to be pi 1 half e squared minus half over 6. You could write this over one denominator, but I'm not worried about that. If you get to this point, that's fine. And again, for these, I didn't put the units cubed. I'm not worried about that for this module. For later modules with engineering and stuff where you use units, that will then be important. Okay. So if you're measuring the strength of something, that's going to have units. The unit you're going to get that will have units there. I'm not so worried about it for you. Any questions about this one? No questions. Any questions for the quiz? Remember, it will be one question on one of these, one of the tutorial stuff, one question on those moments,